Hello, I am UGA NARENDRA BHARATHI, BA, third year Aeronautical Engineering. Today, we are going to see about how the computer radiography differs from the conventional radiography, and I will be briefing you about the principle of the operations of the both. First, the key difference between the radiography and the conventional radiography and how they operate. First, we are going to see about the introduction. Computer radiography and the conventional radiography are the methods which will be capturing the and processing the X-ray images. Um, while the both methods serve same purpose, they will differ in approach and the principle of operation. As like the computer radiography will be using certain methods and where techniques and have advantages and disadvantages on both sides for processing the images and X-ray images and so make it useful. Next, we are going to see about the principle of operation of conventional radiography. The conventional radiography, also known as film-based radiography, which uses the X-ray film images to produce the images of a internal structure for body or object. The principle of conventional radiography is based on the differential absorption of X-rays by different material. When X-ray has been passed through an object, it has been absorbed by the denser method such as bones, and which passes through the less dense muscle like muscles and fats, and the X-rays that passes through the objects are captured by X-ray film, which will be creating a shadow image of internal structure. And the X-ray machine will be emitting the beam of X-rays that passes the through an object which is being imaged, and into an X-ray film. The X-ray film is being placed between the object and cascade, which is being held by a film in place. The X-ray film will be developed using a chemical process which creates a visible image of internal structures. This will be creating images. This results of image is a negative with a denser material appearing white and a less dense material appearing black and green. So bean might be seen in the X-ray where that the bones will be shown in a white color and in a and the muscles and other parts of the body will be shown in a green color. You can see in this image where the bones have been shown in white color and other parts of the bodies have been in a gray color. You can also see the ribs also been in white color. Next, we are going to see about the principle of an operation of the computer radiography. First, the computer radiography is a digital imaging technique which can produce high diagnostic images. The principle of the computer radiography involves in using of imaging plates that are exposed to X-rays. Then it will be scanned to produce a digital images. The process replaces the traditional film-based methods like of radiography, which could produce which can offer several advantages, including the radiation exposure reduction, fast image acquisition, and ability to manipulate and enhance the images for a better diagnosis. The image plates, first one. The image plates are used in a computer radiography, which are made of the photostimulable prosper material, which emits the light when exposed to X-ray. The intensity of the emitted light is proportional to the amount of X-ray absorbed by the plate. The imaging plates are be reusable and can be reused multiple times, and it is cost effective than the traditional method of radiography. Next, image acquisition. After the imaging plates are being exposed to X-rays, they have been scanned by the laser beam that release the energy, which is stored energy as in the form of light. All these emitted lights is then captured by a photodetector and converted into a digital signal. The digital signal is processed by the computer, which produce the high quality diagnostic image. When the emitted light has been captured by the photographer, and it will be converted to digital signal. The digital signal will be processing by a computer to produce high quality image, so that you can be which is been printed on a monitor or a screen, so that you can use it for further analysis. Next is image manipulation. um, One of the key disadvantages of the computer radiography is the ability to manipulate and enhance the images for a better diagnosis. The digital image can be adjusted for a brightness, contrast, and other parameters to improve the image quality and high specific area of interest. This allows the radiologist to make some accurate diagnosis and provide a better patient care. Next, we are going to see about the comparison between the conventional radiography and computer radiography. The conventional radiography and conventional computer radiography both are imaging techniques which used in the diagnosed radiology. While the conventional radiography has been used for standard for many years, and the computer radiography is a newer technology which has been adopted over several advantages. The comparison of the main is between the when the conventional radiography uses the X-rays to produce the image, and X-rays passes through the body and absorbed by a film, creating image of internal structure. But the computer uses the other hand, like a digital detector which captures the X-rays and converts it to a digital image and can be viewed on a computer. The advantages are the lower radiation dose to a patient. The patient will be feeling a lower radiation, and it's a for processing time is very less, and a faster image will be displayed on accuracy. Fast image accuracy, which means the image will be faster processed and be created. And it has ability to manipulate and enhance the images digitally. Next, we are going to say about the advantages of the computer radiography. The computer radiography is a digital image technique which uses several advantages of conventional radiography. Like I already said, that increased image quality, faster processing times, and reduced radiation exposure. First one is increased image quality. The computer radiography produces high quality images that are sharper and clearer than produced by the conventional radiography. This is because that the CR uses the digital detector to capture the image, which is being processed and enhanced using a specialized software. This result in which be more accurate image, and we easily manipulated and analyzed more easily. Next is faster processing time. The conventional radiography also offers a faster processing times that conventional radiography. That is, the digital detector used in the CR captures the image in seconds, whereas the conventional radiography requires the film to be developed and processed manually, which can take up to several minutes or even hours. This means that the patients spend less time waiting for their results, and healthcare providers can diagnose and treat conditions more quickly. Reduced radiation exposure. Finally, CR offers reduction radiation exposure compared to the conventional radiography. This is because the digital detector uses the computational radiography, which the digital detector which used in the computational radiography requires a less radiation and produces an image than the traditional film. This means that the patients are exposed to less radiation during their procedure, and which reduces the risk of reduction related health problems. Next, we are going to see about the disadvantages of this. The disadvantage, while there are more advantages over the conventional radiography, while using the computer radiography, there are also some disadvantages we have to consider. Lower image quality. The computer have lower resolution and contrast compared to a traditional film of radiography, which makes it difficult to see the small details and differences in tissue density. While we are zooming for seeing the small objects or small details, it will be a blurred or more not be a um, good quality. The increased equipment cost. The cost of the computational equipment may be higher than the traditional radiography, which will be additionally they may go wrong on cost for maintenance repairs and which will be costing extra, and it's more high economical. The processing time will be a longer one, and the CR requires the processing time to be viewed, which can be longer than the traditional radiography. This results in the patients to be waiting times and the slow workflow in a busy medical facilities. Next, the applications of used in computer radiography. The computer radiography has been revolutionized in many fields of radiography like digital for imaging and analysis, which has been opened up new possibilities in various applications. It will be used in a medical imaging, where for allowing high quality images of bones and soft tissues, which will be improved diagnosis and treatment of varied conditions like fractures, tumors, and abnormalities. And it will be also used in industrial inspections. The computer radiography used in industrial inspection for detailed imaging of mechanical parts and structure. This will lead to the improved quality control and reduced maintenance cost for a variety of industries, including automotive, aerospace, and construction. The security screening. There's computer radiography also used for security for like detailed image of baggage and cargo. This means that improved detection and of contraband and other security threats, making air travel and other forms of transport safer for everyone. Next, image acquisition in computer radiography. The computer radiography is a type of digital radiography which uses the photostimulatable phosphor plate to capture X-ray images. The process of image acquisition involves in various steps. The patient is positioned and the X-ray images machine is calibrated. The X-ray beam passes through a patient and strikes the computer radiography uh, plates, which is housed in a cathode. This CR plates absorbs the X-ray energy and stores in a latent image. The cascade has been taken to the CR reader, where the plate has been scanned by a laser beam. The laser beam simulates the phosphors into a plate, causing them to emit light. The emitted light is directed by a photomultiplier tube and converted into electrical signal. The electric signal has been processed by the computer and been produced by a digital image which can be more viewed on a monitor. The image processing technique in the computer radiography. The computer radiography is a type of digital and which uses the imaging plates instead of a conventional for capturing the X-rays. First, image acquisition. In the first step of processing in the CR is the image acquisition. The image plate is being exposed on X-ray, which is being cause the electrons and imaging plates to become trapped in a metastable state. When the imaging plate is being scanned with this laser, the trapped electrons release the energy in a form of light, which is being recorded by the photodetector and converted into a digital signal. Image enhancement. One of the digital signal is obtained, and image enhancement techniques can be applied to improve the quality of image. These techniques include noise reduction, contrast enhancement, and edge enhancement. The noise reduction filters used to remove the random variation pixel values, which can be a important obscure the important detail in image. Uh, Sometimes there may be a crack in the bones, which may be uh, when we are zooming, it may be a blur or might not be uh, in a good pixel settings, so that it might affect the details of the image. The contrast enhancement technique adjusts the brightness and contrast of the image to improve the visibility of structures. The edge enhancement techniques are used to sharpen the boundaries between different structures in image. The image manipulation. In addition to the image enhancement, these techniques have been applied to the CR images. These techniques uses the image cropping, zooming. The image rotation is to correct the images that have been taken in a correct angle, while the cropping is to remove unwanted area of the image, and zooming is to enlarge the specific area for a closer inspection. Next one is image storage in a computer radiography. The image is being read by a laser scanner, and which is being converted into a digital format, and which is being displayed on a screen. One of the advantages of the computer radiography over the conventional radiography is ability to store the images and retrieve it electronically whenever we need. They can be stored in a variety of medias like CD, DVDs, and network servers, hard drives. The images being also transmitted electronic to various locations to view for the review by radiologists and other medical professions. This allows for faster and more efficient diagnosis and treatment of patients. Image display in computer radiography. There have been two methods for image display process. First is plate scanning. After exposure, the plate is removed from the casket and been scanned by the laser beam, which process the laser of stored energy from the phosphor and produce a latent image of the light. The scanned plate is then processed by the computer to produce the digital image, then involves in several steps, including noise reduction, image enhancement, and contrast adjustment. This resulting the image can be viewed on a computer screen or printed on a film. The image retrieval in computer radiography. The first, as we have seen that various methods being used for the image processing, while the image retrieval. The plate scan. First step is the image retrieval in plate scanning. The plate has been scanned by a laser beam, which is a stored energy is released in the phosphor plate and creates a digital image. After the plate has been scanned, the digital image has been processed using a specialized software. This software enhances the quality image and corrects many artifacts and distortions that might occur during the scanning process. Once image has been processed, it has been stored in a digital format and can be retrieved when needed. The image retrieval in computer radiography is the fast and efficient process, allowing the healthcare professionals to access it quickly about the images of diagnosis and treatment planning. Next, we are going to see about the quality control. The image quality assurance. The artifacts and image quality must be ensured which meets the standards, and while monitoring and maintaining the performance of CR system, including laser and scanning processing. Exposure index calibration. The exposure index is the numerical value that indicates the exposure level required for producing the diagnostic image. It results in calibrate of VI regularly to ensure accurate and consistent image quality. This means that exposure of phantom known as radiation dose and verifying that L value matches the expected value. Phantom image analysis. It used to evaluate the performance of CR system, including spiral revolution, construct, and noises. The essential to analyze the pattern image regularly to detect any changes in the system performance or any adjustment necessary. The maintenance of the computer system. First, I have to clean the imaging plates regularly to prevent dust and debris. Use a soft lint-free cloth for the mild cleaning solution recommended by the manufacturer. Inspecting of the imaging plates and scratches or damage which affect the image quality. If any damage, we have to replace it. And check for the laser options and calibration regularly to ensure the proper alignment and accuracy. Inspect the CR reader and a computer system for any signs of wear or damage, which replace any faculty components are needed. Next is radiation safety in CR. Using appropriate shielding such as lead aprons and thyroid shields to protect the patients for unnecessary radiation exposure. To ensure the CR equipment is properly maintained, calibrated to minimize the radiation exposure required for producing high quality image. follow ALARA principle, which means the low reasonably achievable to minimize the radiation exposure to the patient, healthcare workers while obtaining diagnostic image. The main comparison is about the image quality, where the digital we are going to see about the comparison between the computer radiography and digital radiography. The digital is another type of digital imaging which uses a flat plate detector to capture X-ray images. Data sends the image directly to a computer, which can be viewed and manipulated. The image quality comparison. The digital produces a high quality image than CR, which is better construct and resolution. The speed is being generally faster than the CR, and images will be instantly. The cost is CR is less expensive than the DR, which makes more cost efficient option for some facilities. This is the future. The AI and machine learning algorithms have been integrated with CR to enhance more accuracy of diagnosis and reduce for time taken. The development of portable CR systems that can be used in remote locations for disaster zones are feasible. The use of CR in conjunction and other imaging modalities such as position emission tomography, PET, and other computer tomography to provide more comprehensive diagnostic information. Conclusion: the computer radiography and conventional have their own strengths and weakness. When the computer radiography offers the advantage of digital processing and storage, while conventional produces workflow and more cost efficient for smaller facilities. The choice between two methods depends upon the specific needs and the resources needed by the facility. Regardless of the method chosen, it is important to understand the principles of operation and follow proper safety protocols to ensure accurate and safe imaging of the patients. For reference, the computer radiography versus conventional radiography are literature review by radiologic technology by Johnston R.L. 2012 and digital radiography. The future is here. The Journal of the American College of Radiography by Cannell K.M. of 2007 and Essential of Radiography Physics and Imaging Elsevier Health Science by Maidment A.D. and Jones A.K. 2008. Thank you.